like you all, but it's been no bed of roses.
All right, then. Good morning, everybody. Did we get everybody? That was Axel coming in at the last moment. Just missing. Oh, no. Everyone is here. Okay, excellent. You're all here. Wonderful. So today we get to start moving mountains. We've got one last topic of the semester. That is circles and their special properties and all the extra, well, not all, some of the very fun stuff we can do with circles. There's still a lot more out there. We're just going to hit the highlights. Here are the biggest features of circles you will need for the SAT. Okay? So without further ado, here we go. We're going to start with the tangent properties. So real quick, so we're all on the same page. Let's run through a review of all of our circular vocabulary terms. And I'll go down the line 1 through 10. You give me the letter that best matches each one. So from this list, can you tell me which lettered image or symbol or something represents the congruent circles? Number 1, where are the congruent circles? Go ahead and add that to chat. Votes, where are the congruent circles there? I've got 1 vote in, and everybody participating today. I better see 11 letters down there. That's 2. Congruent circles. 2 circles, same size, same shape. Well, they have to be the same shape. They're both circles, right? That's 3. There's 4. All right, everybody to attention, to your keyboards. Tell me which letter best here represents the congruent circles. Alani with the lowercase. All right, thank you. That's 5. Who have I not heard from yet? Giselle, I need to hear from you. Jonathan, I need to hear from you. Eddie M. For you. Noe. There we go. Thank you, Christian. Axel, need to hear from you.
Can you repeat it, please?
Number 1, congruent circles. We're just matching this guy to these guys over here. Which letter here represents the congruent circles? Six. Got 6 good answers. There we go. Thank you, Axel. Right. Noe, Eddie M. I still need your answer.
So we just sent it to you privately and that's it?
Say again?
We just sent it to you privately?
Yeah, in the chat.
Oh, okay.
All right, thank you, Jonathan. All right, Giselle, thank you for your answer. It is not correct, unfortunately. Remember, congruent means same size and same shape. The two circles represented here in E are not the same size. This one is significantly smaller than the other. There you go. All right, thank you, Eddie. Yes, everyone, press F in chat to pay your respects to the congruent circles, right? They're both labeled here as 3 inches radius, so they are both the same size. That makes them congruent. All right, the concentric, I kind of gave it away, Giselle's answer. The concentric circles are these two right here on E. They share the same center, con with centric center, right? Sharing the same center. All right, and from this diagram here, which of these, I bet you it's one of those, represents the radius? Tell me in chat. Number 3, which letter describes the labeling of a radius? Got one answer. Come on, everybody, this is supposed to be fast. It's supposed to just see the stream. Letters go by. There we go, that's 2 answers. 3, 4. 5, 6, 7, 8. Very good. Eddie, we were just talking about E. It's not E. That's this guy here. You're going to need one of these that's labeling something. There's lots of radii drawn in here. You might use the letter E on here, but which item is it? A, B, C, or D is the radii. There you go. C, yes, right? C, O to E, O being the center. Very common with most circle diagrams. They love to default, call it circle O at the center, probably because an O is a circle letter. Okay? And O to E is the radius there. Then, of course, we have the chord, DC. Chord goes across a circle, not through the middle. Then it touches the circle at 2 points there through the circle. The diameter, AB here. And the tangent, this is the big one because that's what we're focusing on today. The tangent is this line right here that touches the circle at 1 point. Boop. It just hits it and keeps carrying on. So that would be line TG or item B there. Okay. And we can say 7, 8, 9, 10. And with the central angle, a central angle is any angle formed at the center of the circle as its vertex. So any 2 radii can form a central angle. Okay. So the one labeled here would be, let's say P to Q, well that's a diameter. R, Q, this is the arc. We need an angle. It's to be an angle. P, T, R then is the only angle listed there. These are all arcs as indicated by the little curved bit above them. The central angle there is J. We've got minor arc. That's going to be less than half the circle. Major arc, as it sounds, bigger, more than half the circle. So a minor arc might be R to Q. That would totally work. P, R, Q is half the circle. That would be our semicircle. And P, Q, R, all the way around here would be the major arc. All right. Any confusion on those terms? They show up again. You will know exactly what we're talking about. Then the thing we're going to add today has to deal with that tangent, and it comes up and does a couple different interesting things. So let's use this example question for our exploration. Here I have a circle N, and it's got two radii drawn in. I've got this point T way out in space, something apart from the circle, and I've drawn two lines here. They're both tangent to this circle. So this TA is tangent here, and this TG is tangent here at G. And you might find something like this. Find the angle T. What is the angle inside here? The only thing we know is that this portion of the circle out here is 220 degrees. That's that arc there is 220. But clearly that can't be the same as this angle, right? That would be nowhere near 220 degrees. 220 is more than 180, right? It's more than halfway around. It's a reflex angle. This is definitely at least acute. Okay, we got to get within that range, less than 90. So what can we do here? Well, if I was to ask you, what kind of angle do you think is right here? What would you say? Give me a number in chat. How many degrees do you think that is? Between the tangent line and the radius there. 'Cause I'll bet your intuition is pretty good here. Emily's got a good idea. Jasmine's got a great idea. If you had to guess, what would you pick? Actually, you're trying to overthink it. Right? Yeah, there you go. Top most common answers in geometry, right? Whenever we're dealing with angles and degrees, the most common answers, 90 degrees, 180 degrees, right? It's definitely not 180 degrees. That would be all the way across the whole line. So this is Eddie also trying to overthink, but well, it doesn't quite look. Yeah, and that's why we don't go based on the diagram, right? I'm not trying to actually measure this. I'm not trying to suggest, well, it looks close enough, therefore it is. What I'm saying is I bet you could intuit, you could test our hypothesis here. We are going to say that the tangent lines are always perpendicular to a radius drawn at the point of tangency, which is to say 90 degrees or a right angle, as many of you have said there, right? If I can do one better than that little arc, we'll do it in the classic red. That's a 90, and that's a 90, right? Turns out that is always true. We'll save exploring and proving that for next semester, all right? But yes, tangent lines are always perpendicular to the radius drawn at the point of tangency, right? So if the radius comes out and it hits the tangent line right where it intersects the circle, that will always make a perfect 90-degree angle. Anything other than that, if you try to bend this and make it not a right angle, this won't be a tangent line. It'll end up, if I was to try to make this angle smaller, think about that. If I had a line here, I tried to make that smaller. Look what happens. At the extreme end, I'm no longer tangent, right? Now I'm going through at 2 points. Right? The only way to be tangent is to be perpendicular out to that point. So that's pretty handy, because now we know quite a few things about this diagram here. We know that this major arc is 220 degrees. And we could, of course, subtract from the whole circle to find this minor arc, couldn't we? 360 minus 220. What does that give us? $140? Double check my math there. Anybody get something besides 140? right? So that's the arc here. And if you recall, central angles, like A and G is, remember, the central angle always matches its intercepted arc. So whatever this arc is, this central angle will be also, so this is also 140 degrees. That's pretty convenient, right? So we can just subtract from 360 to get this side, and that matches that side. And now, here's where the visualization skills come in. I need you to see this quadrilateral now. Ooh, quadrilaterals. Roll way back in your head. It's been a while. But notice, we're trying to find angle T. We're wanting angle T. We have 3 out of 4 angles in the quadrilateral. Can we solve for angle T? Yes, we totally can, right? So the sum of the angles in a quadrilateral is 360. And we just need to subtract off everything we got. Subtract that 140. Subtract the 290s. And what are you left with? Type your answer into the chat. Emmeline and Alani, very good. Jasmine, Eddie, you've got it. The team has got it, very good. 40 degrees, right? Angle T must be 40 degrees. And I love how that brings so many little things together there, right? We've got arcs and central angles and circles and tangents and radii and quadrilaterals. In fact, this is a somewhat special quadrilateral because we know that the radii here all radii in a circle are the same length, so these are congruent. And I've got these matching angles here, and I've got, turns out 140 and 40 then are supplementary, right? 360 if I focused on doing those bits first, I would be down to 180 minus 140. I'd just be finding the supplement of this. That's kind of interesting. What shape do you think this might be? What special quadrilateral does this qualify for? If you were to stick this on a string and run out into the wind, it'd take off on you, right? This is a kite. It looks like a kite. It matches many of the features of a kite. The only thing we're missing is, wait, we're supposed to have 2 pairs of congruent sides. So doesn't that mean that this side has to be congruent to that side if it was a kite? Absolutely. That is 100% true. And that leads us to our final tangent property. If you have 2 tangent segments coming from the same point, right? So the same point makes 2 tangents, 1 circle. Those segments are going to be, switch back to blue, congruent. There we have it, by way of making a kite. Oh yeah, those are going to be equal. And so now we can use that every time forwards direction. Knowing that ahead of time lets us save a lot of trouble. Okay? This is particularly interesting. Now that we're dealing with circles and tangent lines, space problems come up a lot, right? Global positioning satellites circling around the Earth, and we want to know, okay, the distance of this satellite from the Earth to here. And so this kind of thing comes up quite a bit. Turns out it doesn't matter which side of the Earth you go to from the satellite, it's going to be the same distance to reach a tangent point there, to reach a tangent point there. That's the limit of your view, right? Imagine this is like your eyeball here. You're looking at a sphere. This is the limit of your view. You can't see any of this back here, so that comes into like eclipses and shadows and All this good stuff based on this idea that these two distances have to be the same. I just thought that was nifty. All right, any questions on those properties so far? No? Then, your exercises for today, okay, some of them get a little complex here because one wasn't interesting enough, so they throw multiple circles in at you. That's okay. Just work through it step by step. Use your fact that you know some things are right angles. You know that, hey, there's like triangles here. What do you know about triangles? This looks like some kind of quadrilateral. What do you know about that? Right? Very doable. Very doable. Okay? And you're going to go through 1 through 6. 7 is based on constructions. We're not doing constructions this semester, so go ahead and cross out number 7. You can skip that guy. Just do exercises 1 through 6 for today. Right? And with that, I will leave you to work the rest of the period. We've got, oh goodness, whole 24 extra minutes, okay? That's like 4 minutes per question. You could do it.